Wrapping up this week and getting ready for your quiz tomorrow, we're going to talk about solving equations with variables on both sides. I did warn you in yesterday's lesson that there would be some modeling in today's lesson. Fortunately, it's only going to be used to illustrate the strategy. This lesson introduces us to variables or problems with variables on both sides. So let's just see how modeling helps us understand better. Again, the modeling itself is not a strategy that you want to rely on. I think I see some people using it on their quizzes, and that's great, but you don't want to use it too much. For example, I'll show you a problem that you don't want to have to model that you might see later on in math. And that would be something like 23x plus 87 equals 95x minus 83. Can you imagine writing 23 cups, 87 pluses, 95 cups, 83 negatives, and having to do that work? So again, the modeling is not meant to be a strategy for you to use all the time. It was just a strategy, kind of like giving you a teddy bear, so to speak, that you have to kind of outgrow over time. So I hope that you are slowly starting to let go of modeling. But again, it's just there for your strategy. So what we're going to do is model this problem and discuss why we are doing what we are doing. So 4x plus 3 gives me 4 cups and 3 pluses. Equal sign, of course, is a wall. 6x means 6 cups, 4, 5, 6, and 7 negatives. And again, keep in mind that in all of our modeling questions, our overall objective was to get the cups alone. But here's where I want to discuss the strategy. If I move these 3 pluses away from these 4 cups, notice they move in with these cups. If I move these negatives away from the cups on the right, they move in with the cups on the left. And so strategy-wise, whenever you've got cups or variables on both sides, you really can't make a move because you haven't declared a side yet. And so whenever there are cups or variables on both sides, your first objective, yesterday I told you that your first objective was to handle the mess. Whenever there's a variable on both sides, your first objective is to declare one side only. And so what we are going to do is move cups to one side or the other. Now the question is, which cups do you have to move? The honest answer is it doesn't matter. But for me, what I would say is it's easier to move the smaller amount, so I'm going to move the 4 cups over here. And what happens is you have a positive cup and a negative cup. Remember, the upside down cup is negative, and they cancel out. And then there's 0 pairs, of course, to go over here. And what comes down is 3 pluses, 2 cups, and 7 negatives. 3, 4, 5, 6, 7. Now it looks just like it was yesterday. Again, that is why last week, which is why I was so tough on you last week, because this is what everything ends up looking like in most of the problems you have. Now we want to get the cups alone by moving the 7 negatives. We do that by adding 7 pluses, 3, 4, 5, 6, 7. We end up with 10 pluses, 3, 4, 5, 6, 7, 8, 9, 10, and 2 cups, which of course, as you know, both cups get 5 pluses, which of course means that x is equal to 5. So again, that is what the modeling was for, just to kind of show you. So the general idea today is if there are x's on both sides, you must declare. Yesterday I wrote the word mess. Today I'm writing the word declare. You must declare one side. You cannot work out a problem and solve having 2 sides for your x. So again, notice once we had cups on one side, the problem just took care of itself. Also notice we moved the cups the same way as we moved the plus and minus signs by just using the opposite amount. So let's just look at some basic problems with variables on both sides before moving on to some trickier ones and moving to your Math XL. So you have 3x plus 4 equals 5x minus 10, and when we draw our wall, we notice that we have x's or cups over here as well as x's or cups over there. And so what I'm going to do is move my smaller amount of cups or x's. Because this is a positive 3x, I'm going to move it with a negative 3x. That cancels out. 4 comes down. 5 minus 3 is 2x minus 10. Now that x is over here, I need to move the negative 10 by adding 10 to both sides. Getting 14 is equal to 2x. And our last step is to divide by 2, getting the answer of 7. Again, once we moved our x's over there, this looks just like our work from last week, so hopefully you've worked on that skill over the last few days or so, because you're going to need them. Now yes, this is the same exact question, but I did this just to prove to you that you don't have to work it out one way only. Last time I moved the 3x to the right side. This time I am actually going to move the 5. This is a positive 5x. I will move it with a negative 5x. 3 minus 5 is negative 2x plus 4 equals negative 10. That is part of the trick you have to pay attention to. If that 10 is negative, you must bring it down as negative. Now we have to get rid of this 4, and we do that by subtracting 4, because remember it's a positive 4. Negative 2x comes down with negative 14. Keep in mind we don't like negative x's, and again my suggestion for you, and you'll hear it all the way through, is to switch first, divide second, getting the answer of x equals 7. Notice here it says x equals 7, here it says 7 equals x. The answer is the same. I did that just to prove to you. For those of you who love to ask me which one do I need to move, it does not matter which one you move. Just think ahead, start using strategy, and sometimes it's better to move one over the other one. For example, if I had 2x plus 3 equals 5x, it would not make sense. I mean, you can do it, but it would not make sense to move my 5x over here, because then there's nothing over here and I need to move my 3. What would make sense is to move 2x away from that so that I have nothing else to go to. But again, that strategy, that's more like a preference thing. It's not something you'll really be wrong on as long as you do your steps right. Working out one more, and again I'm just going to work this out and follow my rule. My rule is that I usually move the smaller amount. So if I have x plus 15 equals 5x minus 1, I am going to move the x because 1x is smaller than 5x. And when I do that, I end up with 15, because those cancel, equals 5x minus x is 4x minus 1. I then have a problem just like last week where I simply move the number first by adding it and move the number attached to it by dividing, getting the answer of 4 is equal to x. Alright, so now that we got the idea, we have to add in some messiness from chapter 2.3. Just remember again the following strategy, which is to clean up both sides first, and that should be your first strategy. That's why yesterday was more important than today. First thing you want to do is make sure both sides are cleaned up. That means you can only have one variable on the left side, one variable on the right. You can only have one constant on the left side, one constant on the right. After you've cleaned it up, that's where you want to declare your side, and then after that you solve it as usual. It is a basic 3-step process. I actually made it into 5 to get me through college, but again, these three steps get it. Clean up both sides, move variables to one side, solve as usual. You might even want to write those things down to help you so that you can kind of have a strategy guide as you begin your solving experience. So looking at 2 problems real fast before we go to the video or to your Math Excel, here's what I mean. Step 1 said clean up both sides. Well, if you look at this problem over here, the left side is messy because of some parentheses. So what we're going to do is distribute. 2.25 times 4 is 9. So we get 9x minus, I don't think I need to do it again, so it's minus 9. And if you look at the right side, this is messy because we have a constant and another constant on that side which can be combined. So we end up with 10x plus 10. Now notice what we have is variables on both sides, constants on both sides. So the first thing we had to do was clean up both sides. We did it. The second thing we have to do is declare a side. I'm going to move my 9x because it's smaller to the other side, getting negative 9 equals x plus 10. And now notice once the first 2 steps are gone or taken care of, everything is extremely simple, which it really is. It's just that you have to have the foundation from last week in order to really finish these things out. So again, the reason why I was so tough on you last week is because without that foundation, you're going to have a hard time working through all these problems that you're going to be seeing. One more ugly problem, and you won't even see this on Math Excel, but you might see it somewhere in the future, probably on your quiz tomorrow, is one that has fractions, because again, I think you should be able to handle fractions. You have a calculator, and I'm teaching you all the tricks you need. First off, in this problem, the mess over here is the fact that we have to distribute. So 1/3 times h is just 1/3 h minus 1/3 times 6. If you remember whole number fraction, send the 6 to the top, making it 6 over 3. 6 over 3 is 2, or you can just do your 1/3 times 6 in here and see that your answer is 2. Bottom line, I don't think fractions should be the issue because you have the tools and you have the knowledge to do what you need to do. Now that we are here, the mess to me is not so much that there's more than one thing on the left. The mess to me would be the fractions. And again, I'm talking you through strategy here. We are still in the cleaning process right now because there's still fractions in here. And in terms of the fractions, I've got a 2, a 3, and a 6 that I want to get rid of. 2, 3, and 6, I think all meet at 6, which means I'm going to multiply every single term in this problem by 6. And notice all I do is put a 6 above every term. So you got 1, 2, 3, 4, 5 terms. So I multiply 5 things by 6, and I follow what we learned a couple days ago. 2 goes into 6 3 times. 3 times 1 makes 3h. 3 goes into 6 twice. 2 times 1 makes 2h. This has nothing to cancel with. That just makes 12. 6 and 6 cancel, giving us just 5h. 6 times 2, 12. Again, notice once you get rid of your fractions, it looks a lot better. And then we still have one more thing to clean up, which is the fact that we have variables on one side, more than one variable on one side. 2h and 3h make 5h minus 12. Oh, this is beautiful. I set myself up for something crazy. So 5h plus 12 equals 5h, sorry, minus 12 equals 5h plus 12. And now we have a very awkward situation, which I guess we were going to talk about at some point anyway. What happens now is we have 5h over here, 5h over there. If we move one of these 5h's, notice 5h minus 5h goes away. 5h minus 5h goes away. So what we notice is that all of our variables are gone. And what we end up with is negative 12 on that side, positive 12 on this side with no variables. And here's where you need to learn the point that I really wasn't ready to teach you, but I guess we can talk about it right now. If your variables ever eliminate completely, first off, check to make sure you did what you were supposed to. That would be a 3, that would be a 2. It does make 5, and they cancel. Here's what you have. There is a phrase called all real numbers, which means that there's a whole bunch of answers to this, and that is if what you have is true. There is also an answer called no solutions, and that is if what you end up with is false. What I mean by true is if after your variables go away you end up with 2 equals 2. Notice 2 does equal 2. That is a true statement, so you would say all real numbers. If I had negative 4 equals negative 4, that would be a true statement. It would be all real numbers. If what I have is something like 1 equals 7, which is a false statement, that means that there is nothing that will ever make this true. Looking at what we have here, negative 12 equals 12. That is false, which means your answer is no solutions. Alright? So I'm sorry I kind of threw that on you like that, but like I said, we'll see a few of those here and there, and we'll talk about it as we go. And the good news is you have computer work that you can always bring up to me, and I'll answer whatever questions you have. My best advice for you is that you work through the problems and learn from your mistakes. Kind of like if I'm trying to prepare you for life, I can't tell you everything because there's certain things you have to experience on your own. That's how math is sometimes. There's only so much I can show you, and the rest is just going to be learned from your own experience. So for now, I won't even say that. We'll not do that. Just go straight to your Math Excel and knock that out because it is a short day, and let's try to get some of this stuff done for tomorrow's quiz. Other than that, good luck.